Okay, what we're going to do today on this is we're going to take some pictures of a baseball pitching machine and some dimensions and stuff and see if we can attempt to build the primary parts of it, possibly purchasing the less costly parts. The 800 number is 800-547-6843. The other number you can read. But what this does, this utilizes a DC motor and a DC motor controller, and essentially takes AC, turns it into DC. The motor's direct drive to the rubber wheel. The assembly, which we'll take apart, shows the motor mounted in the center of a carriage that supports the motor. This plate turns, pivots to allow the bulb going in here and allows you to pitch flies as well as grounders, or throws them straight. The ball comes in this hole, is trapped in between this pad, and slings right out that direction. This is a rubber pad, approximately 1/2 inch thick. This is about 3/16, possibly 10 gauge, feels more like 10 gauge, rolled into a radius, receives the ball comes in, wedges in here, and turns and slings out that way. Very simple, straightforward. What we'll find out when we take it apart is how the motor is actually secured, and it appears that the thrust weight of the wheel is probably going to have its own bearing, but it possibly uses the end motor bearing. Won't know that till we take it apart. Simple, straightforward. Adjusts up and down, turns sideways, and this adjusts to go to the grounder into there. And we've got a tripod stand which could be built in any method. Okay, before we go on, we're going to get some information on this tire so we'll know exactly what we've got. As you see, it's a 4x4.80 by 8. Not for highway service tire. Made by Dyco. It is a tube type, 2-ply rated, maximum inflation pressure 35 pounds per square inch. Special service. Color of this tire is white. Don't really know about that. I don't think it has to be white. Probably putting baseballs into it. It's better not to discolor them. The information on the pitching machine on the top says maintain 16-17 pounds tire pressure. Danger, be sure hitter is ready. Some blah 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 blah. Okay, here's what it looks like without the drive wheel on it. This appears to be a housing that houses and probably the motor bolts too. I think this one is a bearing carrier. That probably is an extra bearing to take the lateral thrust when the baseball goes and gets pinched in between the rubber pad, and it would throw unnecessary torque on the small bearing that would be in the end. I think we'll find a bearing on the inside of there. Essentially this ties to this, looks like. Don't know if we get it apart further. Probably this boss right here, and probably another one or two just like it goes through the face of this. Anyway, this bearing retainer bolts on with these cap screws here. Those are Allen headed cap screws. What we're going to do now is loosen these take this hub apart and slide it off. I'll measure this dimension right here, and I also have the keyway marked as to where it falls. It looks like that this key being cut in here and over here looks like it's intended to be keyed on the shaft, but in this instance it's not keyed, probably for slippage. If the machine locks up, this might allow it to slip by not keying this into this keyway in the shaft. I'm removing the hub that carries the wheel. It's simply a little cast hub with a tightenable center on it through these two Allen screws. The slots clamps it on the shaft. Not keyed, again, like I repeated a while ago, not keyed for slippage. These two holes right here are sealed with silicone, and what these two holes actually are is the fact that the motor itself is mounted to these two holes right here, and also this mounting plate has this flange right here bolted to it, and this flange is actually floating also, and the two tighten down on this plate right here by way of this tightening clamp right here. So the stability of this plate comes from the fact that it's mounted rigidly to the base, and the motor itself is actually, there's a pretty good sized gap. I'd say probably 1/4 inch all the way around the motor. The motor sits into this hole, and when I get this thing apart, we'll probably find that there's some long slots cut in this plate right here that allow this plate to be rigidly mounted to this plate, and at the same time have a ridge big enough, a gap big enough in here to carry this plate that sets the angle of the balls to be thrown. It says preload gauged. Most likely is the preload on this large bearing that's right behind this housing right here. I'm sure this bearing supports the torque up and down to keep it off of the motor bearings. The torque up and down of the balls going through is supported by this large plate. With the X4 exterior bolts removed, it comes to find out this holds the whole assembly together. The only thing that these two bolts, which are the same that you see in the back of the motor, are doing is actually holding this face piece onto the motor, which actually mounts the motor to the assembly, just like we determined that it was probably going to do. The plate here that adjusts the throwing arm has Teflon gaskets, both that run on the inside flat part of this hub and on the face piece of this hub, that this presses against and gives it that smooth feel when you rotate this arm to go from grounders to flies to pitches. This hub right here actually ties solidly to this and utilizes this space right here as a shoulder, which bolts up flat against this back plate, which of course, like I said, is what holds the thing upright. This plate bolts flat back here and allows this shoulder here, which is wider than the width of this right here, to let this arm turn up. When this is bolted up flat, it allows this arm to turn and adjust for grounders and flies. And the face piece is machined to hold the motor itself. So the whole assembly is actually supported from this main piece. Everything bolts up to this piece right here, running around the axis for this plate. This plate bolts up tight. This face plate on the motor bolts tight to this, which allows the spacing that's needed. This is actually a spacer for two things. This plate, and also for the motor to be spaced out to allow the hub to be mounted on the outside, which carries the wheel. Pretty simple design. Some casting and machine work. Of course, all of this elaborate business for adjusting motor speeds and stuff doesn't have to be here. It could be on a box mounted down here that would just have an electrical cord going up to the motor. All the need for all this casting, really none of this has to be cast. That's a cheap way to do it if you're building in production. This piece here, extensive machining on it. Part would probably run 75, 80 bucks, single piece part. This could be fabricated, sawed out, and the inside ID on what fits here would have to be machined to a specific tolerance also to allow for the Teflon spacer and that stuff to be the right clearances for smooth movement. Anyway, we know how it works. Don't know, depends on what design motor we come up with. All of these parts could change configurations. Well, really not configuration, but change sizes to fit the motor that we get. The shaft on this DC motor probably is the determining factor on what the motor size is going to be. I'm sure probably this company had this motor built or manufactured for them, got their name on it. That shaft size looks to be 7/8. 0.875 shaft size. That bearing right there, it's going to be on the end of that. For support is going to be somewhere probably in the vicinity of looks like around 2.5 inches OD, with maximum thickness is going to be in the area of roughly 15/16. So it's a pretty hefty bearing. I'm sure it's preloaded because there's absolutely no movement in and out or up and down in that shaft whatsoever. It is just 100% tight. It's probably a tapered roller bearing that uses the tightness of these two bolts here that run through the motor to put thrust on the bearing, keep the movement to 0. Well, anyway, that's the configuration of it. This item down here, after I get it back together, we'll look at the radius on it, see what the radius is going to be roughly, give us an idea of what kind of pitch that's going to be. Future reference, this piece right here is roughly 3/4 inch thick. This one is 2 inches thick. This one's a 1/2 inch thick. This one's a 1/2 inch thick. Notice there are 3, actually this is a spring-loaded ball assembly. It's really not a ball, it's just a pusher that actually rides against the surface. Imagine this is, it could be cast material or about anything you want to make it out of. It keeps this thing pushed up against this face when it keeps the slack out of it before you tighten this down to secure it. We're running out of battery power. I'm going to shut this thing down and put this unit back together, and we'll run it and make sure everything's correct, and I'll show how baseball and slow. And what I'm going to do now is, I've got the camera on high-speed shutter. I'm going to show you the way the ball feeds through there. All I have is a tennis ball, not a baseball. That's essentially the way it works. Want to see that again? Doesn't take long. This with the machine running nearly as slow as it'll go. Almost as slow as it'll go. This is as slow as it'll go. Thread about 5 feet out in front of it. With it running fast, it'll go. Probably through it about 100 miles an hour. Well, maybe not that fast. That's as fast as it'll go. Pretty hard, pretty hard. Okay, turn it off. While I had this opening fixing this bad cord, I thought I might as well just take a little shot of how this thing's put together. The main control pod out there is a 5K on. Got a couple of 2Ks there, 100K, and they look like a voltage sense. A couple of transistors, a couple little transistors, not a whole lot to it. Big hairy diodes, and a big ballast resistor. Not a whole lot to the board itself. I'm sure we can handle the board